Hello to all the viewers. Welcome back to the series of Sentaurus TCAD tool. In our previous tutorial, we have gone through the basic of Sentaurus TCAD and Sentaurus Work Bench. We have seen that how does the Sentaurus Workbench work and how you can simulate a device using the various tools in the single environment. However, in this video, we will discuss about the Sentaurus Structure Editor, which we called SDE. Now, the basic objective of this video is to identify the feature of graphical user interface, to study about the various file types that SDE used to generate a simple device structure, to generate the mesh of that structure. We will see that how can we create the contacts and how can we dope the structure. So, the tool is Sentaurus Structure Editor. Let's have some introduction of Sentaurus Structure Editor. Basically, Sentaurus Structure Editor or SDE is used to build 2D and 3D device structure. In addition, it can emulate semiconductor process step as well. However, it has two operating modes, that is 2D structure editing and 3D structure editing. You can create the devices in 2D mode and 3D mode. In 2D mode, you can create the devices using simple rectangular, circular, elliptical and square shape structures. However, in 3D primitives such as rectangles, polygons, cuboids, cylinders and spheres, you can use these primitives and create the structure. However, you can also round the edges by using filleting and using edge blending to create the complex structure that is being generated by intersecting primitive elements. So, we have seen that using SDE, we can easily create any kind of structure. Now, how to open the SDE? As in the workbench video, we have seen how we can open the SDE. Just go to the open terminal in the command line and type SDE. Just type SDE and your window will open. Now you can see a window has been opened which is called Sentaurus Structure Editor. This is a graphical user interface and this window is organized into different areas. The main menu bar, the toolbar, list are in the upper part of the main window, lower part is the command line and the center part is the view window. The blue color window is basically your view window. Here you can create the various kind of structures, various kind of shapes and you can easily view the structure here. However, the white window below the view window is called command line. In the structure editor, we can create the structure using the commands as well and using the GUI interface, and both it is also we can use in the hybrid mode as well. So it is very easy tool to create any kind of structure. Menu bar contains File, Edit, View, Draw, Mesh, Device and Contacts buttons. We know that File contains Load, Save and Print functions. Edit contains Change and existing geometry objects. View, Visualization, Preferences and Auxiliary views. Draw, Drawing and basic object creation. Mesh, defining a mesh strategy called the meshing engine. Visualize the generated mesh and data fields. Define the device, basically define the doping profiles. And contacts, define and edits the various contact sets as well. So we can see that with the help of these buttons, we can easily create the device and edit the device. Now the element lists are used to select the various objects that we can operate it. It has material list, work plane, contact list and selection level list. So this is your work plane, this is your selection level list, this is your contact list, and here you create the device. Now view window has various commands like selection level, body, toggle visibility, contacts, used, delete, property, hides and show all. So all these windows are basically, all these commands are basically used to see the various objects and to edit the various commands. These commands are used to edit the device. The command line window display the scheme script commands corresponding to most GUI operations. Scheme commands can be entered directly at the prompt, and this feature is useful in conjunction with copying script commands from and to a text editor when creating and testing the scheme. So I have already discussed that you can create the structure by using the command line window as well. Or if you want to duplicate the same kind of structure, just copy that particular command that you have created one structure and just copy that command in the next line of the in the command line window, and you will see after copying you will create the new structure with using the same commands. Now we will see that how much types of files are there and how we can use these files. So in structure editor, you can initialize a new model from the beginning or load the previous model. The result can be saved. The main input and output files supported by SDE are scheme script file, that is .scm file, journal file, .jrl file, ACI sat file, .sat file, TDR boundary file, bnd.tdr file, doping and refinement file, .cmd file. All these files are containing the data about a sky data format file containing doping and mesh refinement information in conjunction with the corresponding boundary file, uniquely defined geometry of the model. Now, when you save one file or when you save one structure, it will save the various file types, like Sentaurus structure saves the model geometry in the .sat file, the reference evaluation window and parameters in the .scheme file, .scm file, the refinement and doping related information in the command line is in the .cmd file, and the structure in the TDR boundary file, that is .tdr file. So when you want to access this structure to simulate using the Sdevice simulator, then you have to specify all these commands in the coding text editor. So you can easily fetch those commands, fetch those files from the structure editor to the command editor, because all these files contain the data about mesh refinement, contacts, doping information, and various boundary conditions. So it is very important to understand that how your files are being extracted from the SDE to the Sdevice structure. Now we will create a simple structure for GUI based structure editor. Now I have already discussed that GUI based and script based methods, both the methods we can use to create the simple structure. Now we will see that how can we use both the methods. Let's see how we will create a structure that contain one silicon and one cuboid. We will directly choose draw and create this structure in the 3D isometric view. Now, first of all, we have to choose new from the new command, that we will choose new from the new command. Then we will select the material of the structure. Now silicon, we will select the material of the structure. We can see that a number of materials have been given in the list of the material. So you can use any material according to your device in the materials here. So I'm going to select silicon for that. Now choose draw for the exact coordinates and choose 3D draw and 3D create tool for the 3D tools. Now I would like to mention one thing, that it is not mandatory that you will use all the buttons over here. Now here is auto region name is there, exact coordinate is there, overlap behavior is there, work plane is there. So in draw, exact coordinates we will discuss in the further slides, that what is exact coordinates and what is overlap behavior, what is auto region naming. But I would like to just draw one structure, so I will create one exact structure, and same I will take one cuboid as well. So I am creating a cuboid of one and I'm giving the exact coordinates. I'm just randomly giving the exact coordinate to show you that how we are creating a cuboid. So this is basically a cuboid. You can see it is a cuboid. Now it is made up of your silicon. Now I will connect another cuboid as well, and it is a 3D structure. So we can see that it is how we can create a 3D structure by using the different shapes and different material. So this is all about how you create any kind of structure in the SD. Let's see, now this is the structure that you will see after creating the two cuboids, one of your SiO2 and second is of your silicon. So I hope you will understand that how to create a 3D structure in SDE. So on the left side you can see that I have written some commands. So these commands will automatically come in the command line window whenever you create a new structure. So we don't need to write the command simultaneously. So these commands will automatically come in the command line window. Now let's create one 2D boundary SOI MOSFET, which will have a buried oxide, gate oxide, your spacers, and your polysilicon gate, and body is made up of silicon. So let's start with the SDE editor for the same. To create the device like this, I will open the SDE and press the new Control N, or just go to the file and create the new structure. Now here I can easily create the new structure. To create the new structure, we'll have to activate the mode, that is exact coordinate mode. Now why we are choosing here exact coordinate mode? Because we need the devices of very precise dimensions. So that's why we need to have the exact coordinate what we want. If we randomly choose the device dimensions, then it will definitely create the chaos. That's what we don't want in this device structure simulation. So that's why there is an option is being given by SDE, that is exact coordinates. So first of all, we will select here draw an exact coordinate that we have already selected in our previous one. So it is already being selected. So the next thing is selecting the material. This thing we have already shared, that how we can select the material, that is silicon is already being selected. Now after that, all the regions that we will create will be of silicon. But if you want to change the material, then first before drawing the structure, you need to select the material. Like if you want to draw the silicon dioxide material rectangle, then you have to select silicon dioxide. Then after that, you need to draw the rectangle of silicon dioxide. Now here we will see that how we can easily create the rectangular region using the exact coordinates. Now I will choose here rectangle, and it will be of, let me just choose XYZ coordinates, and now it will be particular as rectangle. So I am here choosing -0.2 to 0.2, and Y coordinates 0 and 1. So a proper material has a proper rectangular silicon rectangle has been created with the exact coordinates. So you can see that your material has been, or you can see your substrate has been created with the silicon material in the rectangular form. So after that, we would like to draw the next figure, that is, one is your gate oxide, nitride spacer, polysilicon gate, buried oxide with these dimensions. So let's see how we can create all these with these dimensions. Now we can see that we have easily drawn the various coordinates with the rectangular shape and with the different types of material. The pink material is basically polysilicon. The yellow material is basically your silicon nitride that is being used for the spacers. This brown material is silicon dioxide, which is used as gate oxide. So we can see that we can easily create the device. Now let's see the next procedure. Now after creating the device, you need to round the edges. It is optional that you can round the edges or not. But in this video, we are going to see that how we can use the fillets to round the edges. So to use the fillet, choose edit parameters. A parameter dialog box will display. Choose edit parameters. Choose edit. Choose edit parameters dialogs will come. Then in the variable field, enter the fillet radius in the value field, that is 0.08. Fillet radius is 0.08. Now we will set the fillet radius as 0.08. Then you can close. Now click the select button on the toolbar button, that is select on the toolbar button, and then click the upper left corner of the spacer to highlight the vertex. Select the upper left corner of the space, just zoom in and select this corner. Select the vertex. Then choose the edit 2D edit tools. Choose the edit 2D edit tools and choose fillet. So just fillet radius is 0.08 and fillet. Okay, now you can see that the fillet has been round, create the round edges on the spacer. So see how beautifully it looks. For the right side, we will repeat same steps to do the round edges of the spacer. Now see that how beautifully it has been done. Now we will define the contacts. So for that you just need to choose the contact sets, and in the contacts you need to add various contacts like source, drain, gate, substrate and body type. Now for each contact we will define the color that is being created by the edge color, that is 101. It will create a different color, that 110 it for drain, gate and substrate we will give the different binary value and it will create the different colors. So we can see that by using this we can easily create the contacts. So on the simulation SDE we will see that how we can easily create the contacts. On now here just add gate, this set drain, change the value of the color, source, change the value, substrate, now you can close this. Again set contacts, you'll have to activate each contact. Just click on the contact and activate, and you will see that here in this window you will see the different contacts. So it will help us to create the different contacts on the structure. So on the structure we can create the contacts using the edges. using the boundaries, or even using the region edges and faces. So in this video we will use the edges as the contacts. So for contacts, this will be my source edge, this will be my drain edge. So we can easily create the contact by selecting the edges. Like in the pink and the yellow, I have select the drain and the source and the drain side. Now I will show how I will just select here gate and select the one edge over here and just set the contact. So you can see red color has been appeared. You can easily create the edge as the contact. Now here I would like to the substrate as the contact. So I will select the substrate and set the contact. Now we can see that color has been changed. So we have successfully created the contacts as well. After creating the contacts, you just need to add the vertices. It is optional, it is not required in all the devices, but if you want to do that, you can easily go through these steps that I have written on the slide, and you can easily create the vertices and add the vertices in the device. So the next thing is defining the region as the contact. We can even define the region in the contact. Just select the particular region and its faces or its face or its edges will act as the contact. So you can easily see in the figures that blue color, that is polysilicon, can easily create the whole region as the contact. Now after doing this, you need to save the file. When you save the file, you'll have to press Ctrl S. After selecting the contacts, we need to provide the doping levels. However, we are going to simulate the device, so we have to give the doping. So doping level can be easily specified or defined by using the device. Constant profile level is profile placement is there, analytical placement is there, and uniform placement is there. So in this structure, we will use two types of profile placement. That is, one is constant profile placement and second one is analytical profile placement. So we will, first of all, when you click on device, you will see the window like this. Now placement type, you can place the constant profile in reference window, in region, and in material. In all these three, you can easily just select. Now see region 2, region 3, and material, in which material you want to give the profile placement. Now in constant profile placement, just give the name of the constant profile definition and select the species with the concentration, that is 1e⁻15 for this. So here I'm not doing anything with the decay length or anything. So just add the placement. And close. So your whole silicon has been doped with 10⁻15. In the similar way, you can dope the regions and you can dope the reference window with the different concentrations of the doping levels. Analytical doping level is used in the source and the drain region, because we know that when we are in practical situations, when we are doing the particular regions and particular dopings, we need to give the depth for that. So with this, if we open the device, and choose the analytical profile placement, you can see that there are options for which type of profile you want to take, that is Gaussian profile we want, and name of the profile, what kind of species. Here are doping concentration is for arsenic, boron, gallium, indium, phosphorus, and other you can define. Now you have to give the peak concentration, peak position, or junction or diffusion length. Okay, so in this vector you can easily just add placement and close the window. Similarly, you will give the various kind of profiles in the various type of materials and in the regions and in the various structures as well. Now, in the last but not the least, we have to define the mesh. So for the mesh, we have to select the mesh window. That is how we select the mesh window. That is, just select, define the line or rectangle window. Now just select the whole, okay, and you will select the whole mesh window. So with the mesh we have select, and just after that we have to particularly capture the each area, like your source and drain channel, where you want the concentration of your simulation. So we create that area very much with the very much dense. So here we select the refine window that we have already created, and we will provide the various mesh size, mesh element size. So you can give the mesh element size as small as possible, and after that, but it is a 2D device, so XY direction is sufficient, and minimum you can give is 3 and is 1. So you can just create mesh and close. So here you have already created the mesh. So mesh, after this, that you can go to build mesh, and it will automatically build the mesh. So this mesh will show into your Svisual command. I hope it will show in this video as well. See that in Svisual you can easily see the various all the device has been meshed very adequately. So we can see that with the use of this as a structure editor, we can easily create the device and provide the various kind of properties to the device and easily get the results. So I'm closing this video. I hope you like it, and for the next Sdevice video and for the 3D structure, we will come up with the new video. Thank you. Have a good day.